Download this code and get free GPT-4o from codegive.com, link in the description below. Sure. Reversing a linked list is a common problem in coding interviews and is often found on platforms like LeetCode. In this tutorial, we'll go over the concept of linked lists, how to reverse them, and provide a code example specifically for LeetCode problem 206. Understanding linked lists. A linked list is a linear data structure where each element, node, contains a reference, or link, to the next node in the sequence. This allows for efficient insertion and deletion of elements, as opposed to arrays where elements are stored in contiguous memory. Node structure. A typical node in a singly linked list contains two components. 1 val, the value of the node. 2 next, a reference to the next node in the list. Here's a simple representation of a node in Python. Problem statement, LeetCode 206. The problem asks you to reverse a singly linked list. Given the head of a singly linked list, return the reversed list. Example. Input * head equals 1, 2, 3, 4, 5. Output * 5, 4, 3, 2, 1. Reversing a linked list. To reverse a linked list, we can use an iterative approach or a recursive approach. Here, we'll cover both. Iterative approach. 1. Initialize 3 pointers. Previous, initially set to none. Cur, set to the head of the list. Next _temp, to temporarily hold the next node. 2. Traverse the list and change the next pointer of the current node to point to the previous node. 3. Move the previous and cur pointers one step forward until you reach the end of the list. 4. At the end, previous will be the new head of the reversed list. Here's the implementation of the iterative approach. Recursive approach. The recursive approach is more elegant but uses stack space. The idea is to reverse the rest of the list and link it back to the current node. 1 base case, if the head is none or only one node is left, return the head. 2. Recursively call reverse list for the next node. 3. After the recursion, set the next node's next pointer to the current node and set the current node's next pointer to none. Here's how the recursive approach looks. Testing the function. You can create a linked list and apply the reverse list function to test it. Conclusion. Reversing a linked list is a fundamental problem that helps demonstrate understanding of pointers and linked list manipulation. Both the iterative and recursive approaches have their own advantages, and understanding both will prepare you well for coding interviews. Feel free to test out the code and modify it to suit your learning needs.